Hi, in this video we're going to switch to some code and look at truncation, sealing, and floor that we looked at in the previous video. So the first thing is we're going to need the trunc function from the math module. So from math we'll import trunc. And you can always, as usual, do a help if you want on that. It will tell you exactly what it does. It takes some real number. In this case, we're going to use floats, but you could use other real number types as well. And it will convert it to an integral type, and an integer in particular. So let's try this. Let's say we're going to do trunc of 10.3. We'll look at the 10.5, kind of halfway between 10 and 11. And then we'll even look at 10.9. So it doesn't matter how close or how far we are from 10, as long as that prefix is 10 before the decimal point, the truncation will just return the integer portion. So this isn't rounding, this is just basically ditching everything after the decimal point. Now the int constructor, so if we do help on int, you'll notice that int can take a constructor where x can be a number, while in particular it can be a float. So we can also do the same thing. We can say int 10.4, int 10.5, and int 10.9, and you'll notice that it returns 10, 10, and 10 in each case as well. The constructor actually uses truncation when you pass it a real number. Okay, so that's truncation. Next one we have is floor, and again the math module has the floor function, so we can say from math import floor. And again, if you want, you can do the help on floor. And it just tells you what it does. Okay, so this is the largest integer less than or equal to x, as we saw in the previous video. So we can look at the floor of 10.3 and the floor of 10.4. Oops, let's do 10.5 and the floor of 10.9. And again, we will get 10, 10, and 10. So you might think, oh, well, this is the same thing as truncation. Not really, right? The difference is because of negative numbers. So if we look at the truncation of negative 10.4, negative 10.5, and negative 10.9, how about I put trunc around each one? That might help. And trunc. Okay, so negative 10, negative 10, negative 10. As we said, with truncation, we just ditch everything after the decimal point, and we're left with just the integral portion of the number. However, if we take this, and let's go ahead and I'll copy paste, and then I'll change these to floor. And again, I'm just going to copy paste. Then here's what happens. The floor of negative 10.4 is negative 11. The truncation is negative 10, but the floor is negative 11. Again, we saw that in the previous video. All right, so just be careful. Floor and truncation doesn't mean the same thing. And it does when the numbers are positive, but it stops meaning the same thing. They stop being equal when the numbers are negative. And then the last one we have is sealing. So from math, import seal. Okay, and again, we can get help on that method. Okay, so here's the seal function, returns the sealing of x as an integral. This is the smallest integer greater than or equal to x. Again, we saw that in the previous video. So we can look at the sealing of 10.4, the sealing of 10.5, and the sealing of 10.9, and those will all be 11, right? It's going to look for the next basically integer that's greater than those numbers that we have here. Now, of course, when we deal with negative numbers, again, we always have to be a little careful with that, because what is the negative number that's greater than negative 10.4 or negative 10.5 or negative 10.9? That's the next step up. Well, it is negative 10, right? Because think of the number line. Negative 10 is greater than negative 10.4, and that's what we're looking for, right? So we're looking for the smallest integer that's greater than or equal to the number that we pass into the function. All right, thanks for watching. and I'll see you in the next video where we start looking at the round function.